Hey there everybody, this is Mr. Sheeline. Welcome to the video. This is going to be the video covering 4.1 notes. Okay. Just a heads up, in case if you haven't read the Google Classroom instructions. So formatting for the notes are going to change a little bit. So because there's really not a format that I can just send out to you guys for you to fill out notes while we're full remote, and because I know quite a few of you don't really have access to and just full access really to print off materials, because I'm sure some of you do have parents that have printers, but I'm sure they don't want to be printing off worksheets and all that kind of stuff over and over and over again for X number of siblings that you may have. So the way things are going to change is that I'm just going to be giving you guys the full listed notes, but I will be making adding some extra bits in here, maybe pointing out some places where you really should focus in on. But other than that, the notes are easy enough to read. And if you have any questions, you can just reach out to me and ask questions if there's something you still don't understand. So again, I'm not going to be reading through this. I'm just going to be going through and pointing out certain things, adding some extra notes in here. Okay. So one of the first notes that I'm going to be writing in here. So chemical reactions. When you read this, what you really should be thinking of is that these are chemical changes. Okay. We've already talked about chemical changes back in Unit 2. So what you read here is exactly what you should read, what you should have read from Unit 2 when we were talking about physical changes, physical properties, chemical properties. Okay, and a chemical reaction is no different from a chemical change. And so what that then tells you is that down here, all these are the same markers. These are the same markers as chemical change markers. So meaning, the markers that told you in Unit 2, the things that indicate that you have a chemical change, these are the same exact four signs of these four signs are the four signs of a chemical reaction. They're also the same four signs for a chemical change. Okay, chemical reaction is the same thing as a chemical change. Okay. Okay, so just something to point out. And then chemical equations. So up here there are the definitions that you need to know, and you know these definitions of reactants and products. So when you bring them down here to chemical equation, you've got the reactants on the left side, products on the right side, and it's laid out like this. So you'll see it both in word form, maybe like this. A lot of times it'll be more of like a word problem, and then you'll have this. It'll be written out like this. So this is a great example of example of balanced equation here. And this is what we're going to be focusing on, and this is what we're going to be practicing, is balancing out equations and having these weird little coefficients out front. Okay, that's what we're going to be doing. And then as far as this goes, make sure these two hints right here, these refer to word problems. And yes, you will have word problems. And so refer to this, and because when we have the word problems, there's nothing to worry about. You just got to read them and understand the context of the word problems. So if you see the word and, if you see the word reacts with, if you see the word combines with, that should tell you that two substances there's something happening between one or more substances, and it's going to more or less produce something, or it's going to eventually turn into something. And so these words right here tell you that it tells you, and here maybe I'll write this, tells you, it'll tell you, a lot of times this will be the reactants on the reactant side, but it tells you, like it says here, something is happening. Something is happening. Okay. Whereas in down here, so words such and phrases such as produces, to produce, decomposes, creates, to form, and also it also shows this symbol. It's separated by this symbol, the yield symbol. This right here, this tells you something happened. Okay. Past tense. Okay, so this tells you, the first one tells you something is happening. This tells you something's happened. So typically this is going to be, the first hint here is a lot of times referring to the reactants, while this is referring to the products, or at least it's going to lead you to the products. Just keep in mind this language. We'll continue to practice this language, and we'll have some little activities online that'll help you kind of shape how to best read the chemical equations and how to best move forward and know what's reacting, what isn't reacting, what something started off as, what something ended with. Okay, so just keep these in mind. And then looking on the back here, we're going to be adding this to the diatomic. So make sure you remember the diatomics. Like I'm going to put a star next to it. Like, you've got to remember these. Got to remember. I'll write that. Have to remember these. Okay. And the best way you can remember the diatomics is in two ways. One, if you're having troubles understanding what diatomic means, break down the word. Di means two. Atomics means atom. In this case, atoms. Two atoms. Okay. So, and these are the elements found in pairs of nature, and it's going to be all these guys. And if you're worried about, if you're worried that you'll forget those, remember this. Hofbrinkel. If you remember Hofbrinkel, you'll be set and you'll be golden. Hofbrinkel, as you can see, is basically just a mnemonic device that should help you to remember which one's which. So if you're like, if you've got a question that says like, carbon reacts with or mixes with, or carbon, reacts with oxygen to produce CO2. As long as you remember Hofbrinkel, you'll remember that, carbon will just be C, but then oxygen here has to be 2. Has to be, okay? Has to be, because it's being referred to it alone. And so you would write it out as O2. If it's like, say, hydrogen gas, mixes with something else, it'll be H2 plus whatever. Or if it's this chemical yields this stuff and then iodine. Okay, and then if it's just iodine, then it's I2. Okay. So these are your diatomics. You can't forget about them, and don't forget about Hofbrinkel. Okay. So then getting into how it is that we balance equations. So this helpful hint, actually, before we get into it, this helpful hint is going to be really for number 2, like the second equation down here. Because as you'll see, this one, it doesn't really apply since there's only 2 of them. So let's say you're given a problem, which most of them in the beginning are going to look like this. You're going to be given it's going to be laid out such as this, and you're going to be given your reactants and then your products. And remember, I know that because my reactants are going to be to the left of my yield symbol, while my products are going to be over here. So I'll just write that down. Products, and then these are the reactants. Okay, so reactants, products. Okay. So step 1 is that you're going to create a T-chart and count the number of atoms for each element. So you're going to quickly make a T-chart. You're going to write element, or E, over here, number of reactants, number of atoms for reactants, and then number of atoms for the products. Also include your little arrow up there. Okay. And then you're going to read your equation from left to right. And then whichever, and then you're going to write down the elements you run into, in order. So if we start here, we run into oxygen first, so we write O, and then we run into hydrogen, so we write H. Okay. Easy enough. So then we've got to know how it is that we count these atoms. So when we look at this O2, it's not terribly obvious in the beginning it's not obvious of how many oxygen atoms there are here. Now, because they're both diatoms here, and not only that, it's just the fact that there's a subscript here. So that subscript tells us that there are two atoms of oxygen in O2. Same thing with H2. That little subscript tells us there are 2 atoms of hydrogen. So I'm going to look at that. Oh, there's 2. I'm going to look at that guy. There's 2. Okay. And then over here, it's the same thing. Okay, well, there's 2 for hydrogen, and there's nothing on the oxygen. So that must mean that oxygen is 1. Okay. So if you still have issues with that, and if you still have questions on that, make sure you ask me. Okay. Make sure you ask me what the subscripts have to do with anything. By now, we should understand that the subscripts are just the number of atoms, since we've been crisscrossing and trying to balance out equations for ionically for ionic compounds and acids and also hydrates. So we should know what this is. But again, if we're still struggling there, make sure you ask me. Okay. So anyway, so let's just get back to it. So what we need to do is that we need to have the same number of reactants, atoms of reactants, the same number of atoms on the product side too. So hydrogen is ready to go. We've got 2 hydrogen atoms on the reactant side, 2 hydrogen atoms on the product side. But our oxygen is off, and we've got to figure out how to do that. So that's where step 2 comes in. We're going to be adding coefficients until the atoms on both sides are equal. So if you've got this printed off, or if you're writing notes right now, I would grab a pencil if I were you, because this is where pencils are going to be needed. So we're going to add coefficients. So before we can add coefficients, what are coefficients? Simply put, coefficients are going to be numbers that we're going to be placing in front of our compounds, in front of our elements, in front of the atoms, to more or less factor into that that we're going to be factoring into those atoms, into those elements, into those compounds, to multiply the number of them. So for instance, now this is to disconnect it here and to talk about coefficients, it would be to say this. You put a 2 in front of here, and now you're saying, well, I've got two molecules of H2O. Okay, and that's to say that I have 4 atoms of hydrogen, and I've got 2 atoms of oxygen in this guy right here, because it's like this. It's saying that 2 is going to multiply with the H, 2 is going to multiply with the O. There's already 2 H's, so it's 2 times 2, which is 4. There's nothing on the O, so it would be like 2 times 1 is 2. Okay, so that's what the coefficients are, and that's how we're going to use them, because we need to have the same number of atoms in the products as we do in the reactant side. Okay, so that's what the coefficients are. Okay, and we're going to be using those coefficients to indicate and to increase the number of atoms, because we can't change the subscripts. We can't change the subscripts. So we can maybe add here, because we can't change subscripts. Okay. I'm going to squeeze it in there. Because we can't change subscripts. That's what it says there. Okay, that's why we use coefficients. So let's do that. So looking up here, again, hydrogen's ready to go. We just have to change oxygen. So let's just get oxygen to 2, because it's 2 over here. So to do that, we would write 2 right over here. And again, that factors into here. That factors into this guy as well. So oxygen is now 2, but hydrogen is now 4. Okay. So now I got to get hydrogen equal over here. So I'm looking over on my reactant side now. So now I'm just going to say, oh, well, there's 2 here. And to get to 4, I need to multiply 2 times 2 to get to 4. And that's done. We've got 2 oxygen on both sides. We've got 4 hydrogen on both sides. We have a balanced equation. And our balanced equation would look like this, 100%. It would be looking like this. Now, why is it that we don't put a 1 over here? We don't have to put a 1 over here, because I would argue that you shouldn't put a 1. Because I know there's a lot of students that they write their 7s like this, but they also write their 1s like this. And so it might be difficult for me to know, well, are you putting a 1 down or are you putting a 7 down? Okay? So don't write anything if there doesn't need to be any, coefficient. Don't write anything down, and definitely do not write zeros. Okay, what you're saying then is that there shouldn't be any oxygen in this and that it's 0 times the number of oxygens. Okay, we don't want to do that. And we don't want to say that. Okay. Okay, and then balancing the equations here. So balancing the equations, so this guy's a little bit more complicated, and we're going to come back to the hint that I marked to earlier, but let's just follow the steps that we have so far. So step 1, let's create that T-chart. So I'm going to write E for element, and then number of atoms for the reactants, so number AR, atoms and reactants. And then I'm going to write my little arrow, my little yield sign, and then number atoms and products. And then I'm going to make my T. Okay. I'm going to read from left to right and just write down the atoms I come in contact with. So it's going to be Mn, so for magnesium, or not magnesium, sorry, manganese, oxygen, then hydrogen, and then chlorine. Okay. So I've got my elements labeled out. Now I just have to count them. There's one on reactant side. I've got 1 for manganese, 2 for oxygen, 1 for hydrogen, and 1 for chlorine. Okay. On product side, I've got 1 for manganese. I don't have just 2, but I have 4 for chlorine. Because 2 and then 2, so that's 4. I've got 2 for hydrogen, and then I've got just 1 for oxygen. Okay, so now I've laid out, I have now laid out, how many atoms of each element there are on both the reactant side and the product side. Okay, so that helpful hint that I'm going to take a look at real quick. So balance, or helpful hint, balance elements in order of how many substances they are found in within the reaction, from fewest to most. So that's to say, like this. You look across both in the reactant side and the product side, and you ask, do I have an element that is found in multiple other compounds? Is it split up multiple times? Where do I find these guys? And so a good example would be chlorine. So chlorine is found in 2 locations on the product side. Okay, it is only found in 1 over here, but it's found in 2 places over here on the product side, and that's maybe 1 too many where we just don't want to have to deal with that guy. We'll wait till the end to figure out what to do with him. Okay, and that's what that hint is telling you. Just make it easy on yourself. Focus on guys that are in maybe 1 location over here, 1 location over here, and that's where you should start. Okay, start small. So let's say we do that, so we can clearly see, oh, well, chlorine, we're going to wait to work with you. So now we're left with manganese, oxygen, and hydrogen. But I'm going to look here, and I see, oh, well, manganese is pretty much good to go. I'm not going to mess with him. I don't need to. Or at least right now I don't need to. And then I'm left between oxygen and hydrogen. So it doesn't really matter which one I choose in this case. I can start with either one. In this case, just because oxygen is above hydrogen, let's just start with oxygen. So I've got 2 over here on the reactant side, but I've got 1 over here on the product side. So I don't know, let's try to get this guy to 2. So oxygen is found in 1 location. I'll throw a 2 there, so then that changes that to 2. But it also does change my hydrogen to 4. Okay. So that's kind of a problem. So my oxygen's good now. My manganese is still good, but now my hydrogen's off. So now I need to fix my hydrogen. So let's just add a 4 to fix my hydrogen. So now my hydrogen's good, but it's also affecting my chlorine. And now I got to change my chlorine. And in this case, it just so happens that that works out perfectly. So now I've got 1 manganese on each side. I've got 2 oxygens on each side. I've got 4 hydrogens on each side. I've got 4 chlorines on each side. I have a balanced equation. And if I were to write it out completely, all balanced out, it would be MnO2 plus 4HCl yields MnCl2 plus a 2H2O plus Cl2. So that's to say that manganese 4 reacts with with one molecule of manganese, 4 oxide, reacts with 4 molecules or 4 formula units of hydrochloric acid, and then that yields magnesium chloride here, but also produces 2 molecules of water, and then releases chlorine gas. So that's what this is all saying here, with our important coefficients giving us a balanced equation. So this is what we're going to be practicing. If you guys still have questions for me, if you want to maybe discuss maybe some different methods of how to take notes, I'm all ears. Just let me know what we can do and how to best move forward. So if you have any questions, make sure to reach out to me, send me an email, send me a text on Remind, whatever it has to be. So thanks for watching the video, guys, and I'll see you in the next one.